very successful company with a tremendous track record in this kind of work. And so Eric's just going to talk to you about his work at TI. He's had a number of different roles. I think you can go into maybe which ones you like the most, what you're doing right now, and what you've learned along the way. And I think it'd be helpful for them to learn about where you went to school, what you studied, and the biggest challenges of being an engineer to date. And then they'll pepper you with questions after that.
Sounds great. Cool. How's it going? So, does anyone know what TI makes?
Calculators.
Excellent. We do make calculators, but actually that's only about less than 5% of our overall business. So we actually, the primary revenue generator for TI is semiconductors. So we make the chips that go into everything. So the chips that go into cell phones, into the computers, basically any electronics that you are familiar with, there's usually something that TI has made in those parts. So working for TI has been a lot of fun. I've been with TI since I got out of college in 2002. So it's a little over 10 years now, and things have been a lot of fun. So I guess really I kind of want to keep this relatively informal. And just talk a little bit about some of the stuff that I've done at TI, and if you have questions, feel free to interrupt at any time. All right? Cool. So I guess going back, my father was a civil engineer, and my mom was a teacher, and so really I got involved with engineering pretty early in my life. So we always were doing science fair projects and things like that through elementary school, and so that's kind of how I came to enjoy engineering. When I was in high school, I built my own computer and did a bunch of fun stuff like that, and so it was really, I was always interested in technology. I was always interested in electronics, and so as I kind of got into college and I had to finally decide what I wanted to do. So I went to Rice University, just right up the road here, and basically when I came in, I knew I wanted to do something with electronics, because that was kind of what my passion was. I liked a lot of different things, but I found that I really enjoyed playing with cool gadgets. I mean, when you are able to make fun circuits, you can have LEDs blink, you can play around on computers, take it apart, see what makes it work. That was a lot of fun for me, and so I decided to go into electrical engineering. So electrical engineering is a very broad field. I mean, there's a ton of different subcategories in electrical engineering, and I didn't even know what I was interested in within the field of electrical engineering, and so that's kind of what I spent my time at Rice trying to figure out, is what did I enjoy doing within electrical engineering? Because electrical engineering covers circuit design, so being able to wire up breadboards like that. It covers microprocessor design, so being able to go design a lot of logic to accomplish phenomenal processing tasks. So I mean, the processors that go into your computers or into a tablet or anything, I mean, all of those have a bunch of electrical engineers have written a ton of code to make those circuits actually work. And so it was there's just basic circuit design, there's like chip design, there's the whole dealing with power. I mean, the LDOs, just power regulation. There's all sorts of cool stuff. Signal processing, communication theory. And so I ended up going through and I kind of touched on all those at my time at Rice, and it was a lot of fun. If you're looking for a fun major, electrical engineering is a fun major. It's hard, but it's fun. So I did electrical engineering, and actually between my junior and senior years at Rice, I went and did an internship at TI. So I was doing chip design. So what we do is we actually write software that describes how the chip should behave. So we go and write, I mean, it's similar to what you're doing in terms of trying to control a microcontroller. We just describe what the behavior of a microprocessor should be. And so once we do that, Then we use a bunch of tools that convert that into the actual layout. So the physical drawings of how the wires hook up to everything. And so basically taking what you create on a breadboard and miniaturizing it. So we're talking in the nanometer range. So if you look at like current, where we are, current process technology, the wires are 22 nanometers wide. So we're getting very small wiring to go on inside these chips. And so I was doing writing code to describe the behavior of a chip. And basically we were going through this whole process of creating the actual pictures of the chips so that then the chips could be manufactured and then sold. So it's a very interesting process. There's some videos on YouTube about sand to silicon, and it's a very informative thing if you're interested in how microprocessors get made. So you take just generic sand, and they actually go through the whole process of how is a wafer created, and then when you get a wafer, you go through and you process it in order to get an actual microprocessor. And so it's really an interesting video. So if you have a chance, there's a bunch of stuff on YouTube that I'd suggest that you kind of check out as you start researching what fields you're interested in. So I did an internship at TI, graduated, and then started working at TI. So I did chip design for about 6 or 7 years, and did a whole lot of stuff within chip design. So there's a bunch of different aspects, like any large, complex process. I mean, you talk about your project idea, and when you approach your project idea, you have to start segmenting that into what are the individual steps. Well, any large-scale project is very similar to that. So there are a ton of discrete tasks that you have to go through in order to make the whole thing work together. And so I've done a lot of those different tasks along the way in order to make sure that our chips actually work. But I got involved in architecture. And basically trying to do a higher level of how do these things fit in an overall system, and trying to make sure that we had the right features and that we were actually going to have stuff that was useful to our customers. And so I actually got involved in security, and so security means a lot of different things to a lot of different people. And what we were doing was, I don't know if you've seen all of the news stuff about passwords getting hacked. So LinkedIn, there were a bunch of password breaches for LinkedIn. That we've had data breaches. I mean, every time there's something in the news about security, that's the kind of stuff that I was working on, is trying to make sure that we can protect code, we can protect data from those who would seek to get it and use it for nefarious purposes. So I was doing a lot of security architecture, but at the end, and so as part of doing that, I got to interacting with a lot of our customers, and I found that to be a very enjoyable part of my job. And so then I just recently transitioned to what we call a field application engineer. So now I work directly with our customers, helping them out on their problems. And so I mean, you can kind of, it's an interesting relationship because you have big customers. So my primary customer is Hewlett-Packard. I don't know if you guys know where that is, but the Compaq has an old site, it was an old Compaq site that's north of here, 249 near Louetta. So it's a huge complex if you ever get up there. But when Hewlett-Packard acquired Compaq back 7 or 8, 9, 10 years ago, something like that, that site became the Hewlett-Packard site. And so we do a lot of business with them to do power management within laptops, to do like battery measurements, server stuff. So we have processors that go into thin clients. We have processors that go into power supplies on servers, and so we do a lot of work with HP.
Do you work with the hard drive at all?
So we have gotten out of the hard drive business. So TI was once in the hard drive business. We did a lot of controllers for disk drives and things like that. And so we kind of got out of that. There's there are still some products that we have around that can do hard drive, it can control hard drives and stuff. So, but it's one of the smaller things that it's one of those. TI as a company has kind of morphed itself over the course of time, and so originally TI started out as a geophysical services company. So they were oil explorers, and so they went from oil exploration to chip production, and it was just this winding progression over the course of many years. And we've done a ton of stuff with military. Like we had a military division. We had we had made DRAM for computers for a while, but we just kind of every couple years we look at where are the markets that we really wanted to be in, and we kind of move that direction, and divest ourselves of things that we don't want to be in anymore. So it's a very interesting kind of history of the company as time has gone on. So so really I've been with TI for a while now. Unlike a lot of my generation, I haven't really jumped around to many companies. TI has been my primary company that I've worked for. I did have internships with IBM during college, and I've worked for the county government back in Austin. So I've seen a couple other places, and TI has been a really it's been a fun job, and I think one of the things that motivates me the most, like trying to wake up every morning and figure out why do I want to go to work, is I get to work on a lot of interesting problems. That's what is fun for me. Is we have, I mean, HP as a customer has a bunch of problems. There are a bunch of other customers that have problems, and I get to help try to figure out how we can solve those problems. And they're very cool problems that they're working on. I mean, they're trying to figure out how they can make things like your laptop smarter. I mean, and so they're trying to say, okay, well, what kind of sensors can we add to make a laptop or a tablet more aware of its surroundings, so that it can do things for you automatically instead of you having to constantly tell it what to do all the time. And so there's a lot of cool high level problems that they work on, and so I get to go work on those every day, and that's a lot of fun, and I get to interact with a lot of cool people. One of the folks that I've gotten to know real well over the course of my time at TI is our principal fellow, Gene Franz, and he's done all sorts of stuff within the industry, and it's really quite amazing. And I think that it's been really fun to be able to talk to people like that who were there back before computers were really computers. I mean, they were punch cards that you had a stack of punch cards that you had to go take off to this giant room that had less processing power than your current phone. I mean, so if you think about it, 40 years ago, I mean, or actually about 20 years ago, the supercomputers 20 years ago have about the same processing power as the current generation of the iPhone. I mean, if you think about that, that's crazy how far we've come in just such a short period of time. And so that's one of the things that makes me really excited about working in electronics, working in technology, is that the pace is just so fast. I mean, things are changing so much all the time, and there's just all sorts of new stuff to learn. There's all new problems to solve. There's new stuff to learn, and that's fun. That's what's fun for me is getting to look at that stuff and try to see it in a different way. Try to combine all of the stuff I've learned over the many years, and see how can I apply that to solve a problem in potentially a new way. And that's the fun part about engineering, is understanding problems and being able to work on them. Now, one of the cool things about my job at TI is I've actually gotten to travel a lot. So that's been kind of a side perk. I've been to many places in Europe and over to India a couple of times, and it's been very interesting to kind of get out more into the world and see different places and see how things are different. and not be just completely isolated with an American-centric view, to kind of see what do people think over in Asia, over in India, over in France, Germany, the rest of Europe. I mean, it's really, I mean, it's being able to go there and see some of the cool stuff there, but it's also just being able to interact with all the people. I mean, most companies, most large companies today are global companies. I mean, which is good and bad. It's good because you get to interact with all sorts of cool people who have a lot of different perspectives on things, and that's just a lot of fun to see how do people think about things differently. But the downside is that trying to schedule a conference call between Taiwan, India, California, Europe, and the US is nearly impossible. Somebody's going to have to be up at 3 in the morning to be on a conference call like that, and that can be no fun. There have been some times when I've had to. There was a design review over in Japan, and I wasn't able to go over there just due to other circumstances, and so I had to call in. The call started at like 10 p.m. and they lasted till about 4 a.m. So I had to sit on the phone listening and trying to contribute to this review for 3 or 4 nights from 10 p.m. to 4 a.m. It's really tough, but that's just kind of the stuff that you have to work with. I mean, now it's not all glamour, glory type stuff. I mean, there are some pretty tedious and not so fun things that you have to do, but as a whole, it's always been enjoyable. I mean, there's always stuff that you're not going to enjoy doing, and you just have to figure out what are the things that you're passionate about and make sure that you can do those at least a majority of your time. You're always going to have to do something that you don't really want to do. You're going to have to do paperwork. You're going to have to do documentation. You're going to have to do something that's not as exciting as developing code or designing a circuit or debugging something. I mean, so there's always these tasks that are going to be less fun, but you just kind of have to slog through those because as a whole, you're getting to do something that you really love. So I hope that you guys have a passion for some of this stuff, because I mean, doing engineering and especially doing stuff in electrical engineering, it's a lot of fun. There's a lot of cool stuff out there, and so I would encourage you to find something that you're passionate about, whether that be engineering, whether that be doing something with electronics or something else. Maybe you enjoy doing software, maybe you don't enjoy any of this and you want to go do mechanical engineering and design robots, or maybe you want to go actually do environmental and look at the environment, or do something else in politics or whatever. Find what you're passionate about, because you have to spend a lot of time at work, and if you don't have fun doing stuff at work, it's going to be a long set of years. Time moves a lot faster when you're having fun. So I'd encourage you to try to find something that you really enjoy doing, and follow that, and at least try to do it a majority of the time. Now, if you can't find that through your work, then figure out how to find that outside of your work. I mean, sometimes you just can't find that in a particular job, but get involved in other organizations. Make sure that you're satisfying that need for something that you're passionate about. All right, cool. So that's enough of me prattling on. What questions do you guys have? Either, I mean, I'm open for anything. So history, what I do, parts, problems that you're having. What's fun?
What projects have you worked on, like outside your job?
So I worked on my PhD for a number of years, and I actually did wireless sensor networks. So what we did was we built a small board similar to about the same size as the little Arduino that you guys are working with, but it was a wireless sensor network node. So it had a small little microprocessor, it had Bluetooth for communication, it had some batteries and stuff, and so and a bunch of sensors. And so it could take the sensor data, it could aggregate that all together, and then it had the networking capabilities to now transmit that data back upstream to either another node or back farther on to a host processor. So I got to do that kind of stuff, and it's sensor networks they still have a ways to go, but you're seeing a lot more of that. Like you talk about connected home. So now they're trying to put sensors in basically everything, so that your appliances can talk to each other, so that your lights can talk to each other, and that way you can control every aspect of your house just from your phone. And so that's kind of the evolution that sensor networks have come into, is now being part of adding sense to components, or to appliances, or to things. Now instead of your washing machine just sitting there and not knowing anything, it can understand its current consumption. It can understand what time of day it is. It can talk to upstream to the power company and say, hey, what's the rate right now? So that way you can say, it can let you as a user know, hey, you know, if you started your laundry in a couple hours, it's going to cost you $1 less to do this load of laundry than it is right now. And you can decide whether or not that's worth it to you. Do I need to start it now because I have to be somewhere, or can I wait an hour and have it started automatically in a little while when the rates are cheaper? So there's all sorts of intelligence that's being added to everything. And that's just the fact that we can make these silicon devices really small and really cheap. I mean, it's amazing how cheap you can get processing power today. You talk about I mean even expensive stuff. I mean, like your cell phone. I mean, it's a cell phone's $500, $600, but like I said, it has the same processing power as a supercomputer 20 years ago. So processing power has gotten a lot cheaper over the years. What else? I guess that's just one outside project. I've worked on a couple other side projects, but I'll open it up for other questions at first. Yeah.
What was the biggest project you've ever done?
Ooh, biggest project. Well, that's a good question. All the projects. So big is a relative term. The biggest project I did was actually one of our chip designs. So I mean, the end result is a chip about yay big, but it's I mean, if you look at it from a project management point of view, and the amount of work that went into it, it was probably about the biggest project I've ever worked on. So what we did was, if you looked at kind of the way things have been, the progression of electronics. So what you do is you come up with a system, and you have pretty much, you figure you have a problem, you divide your problem up into all of its subcomponents, you figure out what you need for each of the subcomponents, and you wire them all together, and it works. But that's expensive, because you've designed discrete solutions for pretty much every part of your problem. And so you roll that out as your prototype, or you roll that out as your first production, but next year you need to reduce the cost $50. So what do you have to do? Well, you have to integrate everything. So you have to figure out what are the pieces that I can move in to another, to like my main processor. Can I now integrate my analog, my A to D converter? So I have some real world analog signals. I need to convert that to be to digital so that I can process them. Can I suck those into my main piece of my main processor? And that way I make the whole system cheaper, because instead of having two discrete components, now I just have one component that I just feed the wires directly into. So there's this whole trend of integration, and that's, you're going to see that everywhere. So once you have a solution, the next part is optimization of that solution, and that means integration. So what we have done is, you look at a lot of systems today, and you have your main CPU. I mean, so think about a PC. You have your main CPU, and you have a whole host of other peripherals that sit around it. Well, what we have done is started integrating all those peripherals. So what we call that is a system on chip. So we take a processor plus USB, PCI Express, SATA, power management controllers, and other types of serial ports, and graphics coprocessors, and all of this stuff, and we start putting it all into one system on a chip. So we take all of these discrete components or the components that used to be all these discrete things in a system, we've now integrated it all together into one chip. So that's the idea behind what we do from a chip design point of view. So the biggest project that I worked on was one of our last chips before I moved out of design. What it had was it had a very high-end ARM processor, so something that you'd see in a cell phone or something like that. It had a high-end ARM processor. It had about 3 or 4 video processing engines. It had a whole host of other peripherals, USB, PCI Express, all of this integrated together. And so what we had to do was not only did we have to design some of these components, but we also had to integrate it all together and make sure it all worked as one cohesive unit, so that when we sold it to customers, we could tell them how to make sure that everything worked together. So I was one of the guys that there was a team of about 40 of us that were doing this chip, and so I was in charge of trying to make sure that we verified how the chip worked, that we make sure that there were no screw-ups in how we had integrated everything together in order to make sure that the chip was actually going to work in the end. And I mean, there's just a whole host of things that can go wrong when you're pulling together all of these different blocks and trying to make sure that they all work together. And so that's really kind of the biggest project was this last chip that I worked on. We ended up getting behind schedule because there's always a bunch of different aspects to a chip. There's power, there's performance, there's cost, and then there's schedule. And it forms a nice little 4-dimensional space, and you have to figure out what point do I pick in that 4-dimensional space to make the necessary trade-offs between those things. I mean, I can have all the performance I want, but but it's at the cost of power, and it's at the cost of the trade-off is how much area or how much the chip's going to cost. And potentially how much schedule I'm going to have to invest in order to make sure the performance is maximum. And so you have this kind of dynamic of how do we trade off all these things in order to create the best product for a given set of criteria. So that's where you talk with all your customers about what do you need? I mean, what do you need in terms of performance? What do you need in terms of power? So you get some constraints on your problem, and then from that, you're now able to kind of make the trade-offs that you need for power, performance, area, and schedule. And so we'd gotten behind schedule, and we were pretty far behind schedule, a couple months, and that was not good because there were penalties if we did not actually finish on time. And so that's where you get there's pressure to actually pull in schedule and things like that. And so we were working a long time. So we actually had to set up these conference calls because half of our design team was in India, half of it was in the U.S. And so we had to coordinate. And so the thought about having half your team in India and half your team in the U.S. is that you can work 24 hours because they'll work their 12 hours and you'll work your 12 hours, and India's about 11 and a half hours time difference from the U.S., or at least from Central Time. And so the idea is, well, you can work 24 hours a day because half your team is going to work during the U.S. daytime and half the team is going to work during the U.S. nighttime. The reality is that because of the dependencies, you tend to lose a day on every problem because they'll have a problem and say, oh, can you give me this piece of information? Well, you get that in the morning. By the time you send it back to them, they're already asleep, and so they don't get it till the next day. And so what we had to do was we had to set up a lot finer syncing up in order to make sure that we were not losing a day on every problem, as opposed to, and so we were kind of trying to accomplish that whole working 24 hours using 2 teams, but that strains, it puts a lot of strain on you because you end up having to have conference calls about every 12 hours, and that can be where it can wear on you after a while. So we had conference calls at 11 and 11 every day for a couple, at least about a month, and in order to make sure we got back on schedule. So it was tough, but that's kind of the nature of a lot of engineering, is that you end up getting under the gun because either there's a deadline, or or you have a conference that you're having to present a demo to. I mean, just like you guys ran into last night with Parents' Night. I mean, you have to demo, you want to try to demo your stuff. So there's this big, hard deadline, and so you just kind of have to work as much as you can in order to get everything done. And so it's the same way in the corporate world. So anyway, long, rambling answer, but the biggest project was one of the chip designs that I did.
Do you ever think about being a petroleum engineer?
So chemical engineering, actually my brother became a chemical engineer. And so I never really liked chemical engineering as much. I mean, I enjoy chemistry, but I never really liked that chemical engineering as much as I liked electrical. And so that was where I never really was too serious about doing petroleum engineering. But actually, as in this new role, one of the customers we work with a lot is Halliburton, and so we work with them more on the electrical engineering side. So we're not designing the rigs, but we're providing all the electronic components that go into the rigs. So when they're going to go downhole to do oil exploration, they have a bunch of different sensors that collect data, and then they have to transmit all that data back up. And so there's a lot of actual electronic components that are down there at the end of this giant cable that's digging through the ground. And so I've actually kind of gotten to see a lot more of that. And there's some pretty cool stuff that actually happens as part of that downhole stuff. The biggest constraint is that it all has to work at 210 degrees Celsius, which is really hot. And most of these components that you're using, they work up to about 70 C. And to have to go up to 210 is a big challenge for a lot of things. And so it's actually been really interesting to kind of look at some of the projects that they've been doing in terms of making various electronic components work at these extreme temperatures and extreme conditions, because that's the thing about petroleum engineering and just oil exploration in general, is that it's very extreme conditions. You're at the bottom of the ocean, or you're or you're digging miles underground, and you're doing all of this stuff in very extreme environments for electronic circuits. But you still need to make sure that you get enough data back up so that you can actually find what you're looking for or control the thing effectively. So pretty cool stuff. But no, I'd never really thought about doing chemical engineering. Other questions? So, what year are you guys in school?
Senior. Well, that's right.
Different.
American junior, American senior.
Cool. So where are you guys looking to go to college?
Did you can? Cool.
Awesome. Very good. So are most of you guys interested in doing engineering as a major, or are you still kind of undecided?
You don't know what field.
Exactly. That's always the hard part, is trying to figure out what field you like the best. I mean, like I said, I always enjoyed more the circuits thing. So when I did physics in high school, so you have the physics AP tests. So you have the mechanics portion, and then you have the E&M portion. So I always did the E&M stuff really well. Mechanics, not so much. So I was not nearly as good at the math behind mechanical engineering, and so it was my preference tended to be towards electrical engineering, because that stuff just made more sense to me. The whole motion stuff, rotation around an axis and everything. There's some crazy math, and I could never set up the problem right. I could do the math, but I could never set up the problem right to think about it. And So that's why I would not have been good at mechanical engineering. Electrons are so much easier to think about.
Any other questions?
What do you enjoy doing outside of engineering?
Outside of engineering, so I'm a big anime fan. I enjoy a lot of anime. There's a lot of fun series out there, so I enjoy that. I'm a big bike rider. I do the MS-150 every year, so it's a lot of fun. I don't know if you enjoy riding your bike, try doing the MS-150 one year, because it's an event. So it's about 180 miles. You do it over 2 days. You ride about 100 miles the first day, and you bike. It's a bike ride from Houston to Austin. And the cool part about it is that there's about 13,000 people that are riding. And so it doesn't matter how fast you go or how slow you go, there's always a sea of bike riders in front of you and a sea of bike riders behind you. And it's a great experience, because everyone out there is having fun riding their bike. And it's a good thing. I've done it 5 years now. And so this last year was the most challenging, because I ended up breaking my hand on a fall. But that one, so I had some recovery time afterwards. But I enjoy riding my bike, sports. Both playing and watching. So fun stuff. I'm married. I have 2 kids. One of them is he'll be 5 in about a month and a half. The other is 2, and so that keeps me busy too. Having little kids is a big time commitment, and so it's one of those. Make sure enjoy your time right now. You have very little responsibility. High school, very little responsibility. College, very little responsibility. Enjoy it. Once you get out into the world, real world, into having to work to support yourself and everything, your responsibility starts going up. And then when you get married and now you have to support more people and you have kids and a house payment and everything like that, your responsibilities grow. So enjoy, get out, do fun things right now. Make sure you enjoy this time, because you're at a point in your life when you have a lot of opportunity and very little responsibility. So enjoy it.
That's a perfect way to end it.
Cool.
Right there.